Good morning everybody. I am Mardan Ali Sheikh from Mechanical Engineering Department, BMIT Solapur. Today we will see the basics of refrigeration and air conditioning, which is one of your subjects in the final year. We will start with the definition. We will see the differences between heat engine, refrigerator and a heat pump. We will see the types of refrigerating system that are used practically nowadays, and lastly we will see what are the units of refrigeration. As per the American Society of Refrigeration and Air Conditioning, they have defined refrigeration as nothing but the establishment and maintenance of the temperature differential between a system and the surrounding. That means if you are having a system which is at a unique temperature, that temperature has to be maintained which is at a lower temperature than the surrounding temperature. This is called as refrigeration, the science of refrigeration. Now the major problem that students face during interview and during the exams is they are not having a clear concept as to what is the difference between a heat engine, a heat pump and a refrigerator. Major confusion is regarding the difference between a refrigerator and a heat pump. Today we will see in a proper way what are the differences. I will draw the diagram, just see that. We know that as per the natural law, heat flows from higher temperature to lower temperature. That means it flows from the hot body to the cold body. Suppose if we develop a system which is comprising of a hot body which is at a temperature T1 and heat is flowing from the hot body to the cold body which is at a temperature T2. In between we are having a system, when the heat is flowing across this system, obviously the system will produce some work. If we get a positive work output from the system, this entire system is called as heat engine. That means it is taking in heat from the hot body and it is producing work. That is the final effect we can say. This entire system is called as the heat engine system. In converse to this, if we want to pick up heat from the cold body and put into the hot body, if we develop a similar system, now what is our task? We have to pick in heat from the cold body and supply it to the hot body. Obviously whatever arrows were there earlier, they will be drawn in a reverse manner. This is how it will look. Similarly, whatever work done was produced from the earlier system, in this system work will be absorbed rather than produced. So this will be the system which will pick in heat from a cold body and supply it to the hot body. This is against the natural law. This type of system is called as the refrigerator system. We are picking the heat and we are supplying it to the hot body. There is one more system. In effect it appears similar, but the final effect is somewhat different. Again we are having a hot body, we are supplying heat to the hot body and we are removing the heat from the cold body. Even here the arrows will appear similar. Only thing is that instead of removing the heat, if you supply the heat, just note the difference. Over here in the refrigeration system we are removing the heat. The final effect is removal of heat. In the heat pump, this is called as a heat pump. In the heat pump, rather than removing the heat, we are supplying the heat to the hot body. So in effect this will be Q plus W. So this is the basic difference between a heat engine, refrigeration system and a heat pump. I will tell you once more. In a heat engine, heat is extracted from a hot body. It goes through a process wherein it gives a work output and remaining heat is rejected to the cold body. This is as per the natural law. That's why it is not contradicting any of the laws. In a refrigeration system, the final effect is the removal of heat from the cold body and we are supplying it to the hot body. In between we are taking in work, that is work is being input to the system. Even though the circuit appears similar to the refrigeration system, in a heat pump the final effect is to supply the heat to a hot body. Okay. Now let us see. Obviously these are the some of the mechanical system. Obviously there is some input, there is some output. We have to take a ratio of the output and input, which gives the normal term which is called efficiency. If you take into account the efficiency of a heat engine, this is how we can write down. Efficiency is nothing but the output is in the form of the work. That's why efficiency can be written as equal to W upon what is the input? Input is in the form of Q, or the heat energy. This will be the efficiency of a heat engine. In case of a refrigeration system, what is the input? Input is in the form of work, whereas the effect, final effect is removal of heat from the cold body. Instead of efficiency, we take into consideration a term which is called as coefficient of performance, or we call it COP. COP of a refrigeration system is nothing but what is the output, or the final effect is Q upon W. Input is in the form of the work done. Okay. So this is the difference between a heat engine. So this is the basic difference between the efficiency of a heat engine and the COP, or coefficient of performance of a refrigeration system. Similarly, if you go for the heat pump, we have the term which is called as EPR, or the energy performance ratio, which is nothing but the final effect. Final effect is in the form of supplying heat to the system, Q upon W divided by Q it will be. We can simplify this further. We can write down EPR is equals to 1 plus W upon Q. As you can see from COP, W upon, therefore EPR is equals to 1 plus Q upon W. You can see from COP that COP is nothing but Q upon W. Therefore finally we can write down EPR is equals to 1 plus COP. So EPR of a machine is always more than the COP by 1, by unity we can say. So this is the basic difference from technical point of view, from the practical also, between a heat engine, a refrigeration system and a heat pump. If we have to give a day-to-day example of the difference between refrigeration system and a heat pump, we can say that if you have an enclosed space, if this is the enclosed space which has to be maintained at suppose 25 degrees centigrade and the outside temperature is 45 degrees centigrade, we use a refrigeration system to remove the heat from this enclosed space. This is the example of a refrigeration system, as we use it in the summer season for maintaining the air conditioning of a house. Whereas in case of a heat pump, if you take the same enclosed space and if the outside temperature is rather lower than the inside temperature, suppose if the outside temperature is minus 15 degrees centigrade, if you have to maintain the inner temperature as 25 degrees centigrade, that time the circuit that you have to use is your heat pump. That means you have to take in heat from the outside and put it into the enclosed space. You are putting in heat into the enclosed space. In case of a refrigeration system, you are removing heat from the enclosed space. So this is the basic difference between a refrigerator and a heat pump. Okay, okay. We'll go for the next bit. We will see the types of refrigeration system that are in use. As you must be knowing that the basic activity of a refrigeration system is to maintain the temperature lower than the surrounding temperature. So the easiest method to maintain the temperature at a lower than the surrounding is to put in ice. That was the earliest and the earliest method was ice refrigeration. It might seem that this might appear to be a primitive method, but still it is prevalent in nowadays also, wherein a large amount of space is to be cooled. Even nowadays ice refrigeration is in use. Earlier what they used to do, if suppose they are having a box, in the box there used to be storage space over here. In this, the food articles and anything that has to be refrigerated, it used to be kept in this space, whereas the upper part of the box used to be filled with ice. So in this way, a lower temperature used to be maintained in case of ice refrigeration system. Nowadays, if a large system is there, suppose if you are having 4 different compartments which have to be maintained at different temperatures, we can build up a circuit using the ice refrigeration system. In this circuit, space is there for inserting ice in this system. Ice is kept over here. We put in ice over here and water is pumped over here. This water is removed with the use of a pump and it is circulated through this system. In every block we are having it, the flow is regulated using a valve. This cold water is circulated through the system and it can be brought back to the original chamber. In this way, the amount of refrigeration that is to be maintained in the chamber, that can be regulated by using the cock over here or valve over here. Okay. Second, next we will see which are the type of refrigeration system. Next is we go for evaporative cooling. Evaporative cooling, the best example that we can give is, we use a earthen pot for cooling the water. Earthen pot during the summer season, the basic principle is that whatever pores are there in the earthen pot, they tend to ooze out water. That water tends to get evaporated from the surface. While evaporating, it takes away the heat from the system. In this way, whatever content is there inside the system, that tends to get cooled up. Okay. Similarly, a desert cooling bag is also used. A canvas bag is used. Water is poured into the canvas bag. Whatever pores are there on the canvas bag, through those pores, water tends to get outside, and once it evaporates, it tends to cool the content of the water inside the canvas bag. This is also example of a evaporative cooling. Even though it is not so extensively used for refrigeration system, it is one of the example wherein the temperature inside the system is lower than the surrounding temperature. Commercially, now next system that is used is the use of a dry ice. Now try to remember that dry ice is nothing but solid carbon dioxide. Using of dry ice.